Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session we are going to discuss a solved numerical on the topic motion in straight line. Let's go to the topic. A motor car takes 10 seconds to cover 30 meters and 12 seconds to cover 42 meters. Find the uniform acceleration of the car. We have to find the acceleration of the car and its velocity at the end of 15 seconds. Okay. Initially, at t equal to 0 seconds, the car is in motion here. That initial velocity we don't know, which we have to calculate. First 10 seconds, it covers a distance 30 meter, and the 12th second, it covers the distance 42 meter. Okay. So by using these two observations, we have to calculate the data which required to calculate acceleration of the car. And if with this acceleration, if the car is in motion, then it's 15th seconds. At t equal 15 seconds, what will be the velocity of the car? That we have to calculate. For the reference, first I just write the kinematic equations for our reference. Okay. Kinematic equations. Okay. We know that the three equations such as V equal U plus AT, S equal UT plus of AT square, V square equal U square plus 2AS. Okay. Here, among these three equations, first write the given data. Okay. What is the given data? Given here in the numerical. Okay. So the given data. First 10 second at t equal 10 second, it covers a distance that is 30 meter. This is one observation. The second observation is at t equal 12 second, it covers the distance 42 meter. Okay. So these are all the two different observations. Okay. By using this, we have to find uniform acceleration of the car. That means what is the acceleration of this straight line motion? Then what will be the velocity at the end of 15 seconds? Okay, velocity at 15 seconds, that equal to what? These two things we have to calculate. Go to the solution. Okay, here first we are going to calculate what is the acceleration. Okay, so here among these three equations, here distance and the time we know, and we have to calculate the acceleration. So it's better use the second equation because the first equations and all, we don't know the value of v and u. Okay. So use the second equation, that is s equal ut plus of at square. Okay. S equal ut plus of at square. Okay. Ut plus of at square. Okay. Ut plus of at square. So here, first, I'm going to put the observation 1. That is, t equal 10 second, it travels the distance 30 meter. Okay, so substitute the case 1. In case 1, where t equal 10 seconds, distance equal 30 meters. Substitute in this equation. So we can write 30 equal 10u plus 1 by 2. Acceleration is the unknown. Time equal to 10. So we can write 10 square. Okay. Then the further simplification, we can write 30 equal 10u plus 1 by 2a multiplied with 10 square. That we can write 10 multiplied with 10. Okay. So this 2 we can cancel with a 10 like this. Then we can write this equation as 10 equal 10u plus 50a. Okay. If you rearrange this equation as 10u plus 50a, that equal to 30. Okay. Further, this equation we can simplify, because here 10, here 50, here 30 is there. Commonly, we can divide by 10. Okay. If you divide by 10 throughout the equation, we can write u plus 5a, that equal to 3. That is the first equation. Okay. Now take the case 2. Okay. Where t equal 12 seconds, s equal 42 meter. So t equal 12 second and s equal 42 meters. Okay. So here, same equation, that is s equal ut plus half at square. Okay. Here, I'm going to substitute s equal to 42 meter and the time equal 12 seconds. So here we can write 42 equal 12u. Okay. Instead of t, I substituted 12 plus 1 by 2 a multiplied with t equal to 12. So 12 square, that we can write 12 multiplied with 12. Okay. So I just cancel this 2 with this. We can put 6. So 42 equal 12u plus 72a. Okay. This we can rearrange as 12u plus 72a, that equal to 42. Okay. So here, this equation 12, 72 and 42 now. So divided by 2 commonly throw out the equation. So we can rewrite this equation as 6u plus 36a, that equal to 21. That is the second equation. Okay. So By using these two observations, where t equal 10 second, s equal 30 meter, at t equal 12, s equal to 42 meter, we substituted in the equation of motion s equal ut plus half at square, case 1, case 2, we got two equations, u plus 5a equal 3 and 6u plus 36a equal 21. Now we are going to solve the two equations, okay, by solving equation 1 and 2. Okay. First equation, u plus 5a that equal to 3. Second equation, 6u plus 36a that equal to 21. Okay. Here to cancel the u, we multiplied 6, the coefficient of u in the second equation with the first equation, the coefficient of u in the first equation, with that multiply the equation 2. Okay, like multiply the first equation with 6, which is the coefficient of u in the second equation, and multiply the value 1 with the second equation. The 1 is the coefficient of u in the first equation. Okay. Then we can put, just multiply 6 throughout the equation. Okay. So we can write this as 6u plus 30a that equal to 18. Okay. Same way, this if you multiply it with 1 throughout the equation, we will get the same answer, 6u plus 36a that equal to 21. Okay. Now, to eliminate any one of the unknown, like here also 6u, here also 6u. Here in these equations, there are two unknowns are there, u and a. Okay. So here first we are going to cancel the one unknown, any one of the unknown, simply u. So minus, change the sign on the second equation. Here 6u, here also 6u. Okay. So we can cancel the 6u, 6u. Okay. Then if you subtract this 30a with the 36a, we will get minus 6a that equal to minus 3. Okay. So we can write a equal minus 3 divided by minus 6. If you simplify, you will get 1 by 2, or we can write acceleration equal 0.5 meter second power minus 2. Okay. So now what we have to do, we have to substitute this value of acceleration in any one of the equation. Okay, substitute the value of acceleration in any one of the equation. Okay, then we can get the value of u. Okay, so now what I'm going to do, I'm going to substitute the value of acceleration a equal to 0.5 meter second power minus 2 in any one of the equation, namely the first equation. Okay. So substitute the value of acceleration in the first equation. Okay. So acceleration equal 0.5 meter second power minus 2 that we got. So substitute this here. in the first equation, like u plus 5a, that equal to 3. Instead of a, substitute 0.5. So u plus 5 into 0.5, that equal 3. So u plus, if you multiply this, we will get 2.5, that equal to 3. So u equal 3 minus 2.5. So we will get that equal to 0.5 meter second power minus 1. So u we will get 0.5 meter second power minus 1. Okay. So now we calculated the value of u and also the required value of acceleration. And then we have to calculate the velocity at the end of 15 seconds. Okay. So for this, now we have the value of t and also acceleration we calculated. And we have the value u also. So it's better to use the first equation. V equal u plus at. From this equation, we can calculate the velocity at the 15 seconds. Okay. So velocity at t equal 5 seconds. Just write the first equation, V equal u plus at. Substitute the values. U, we got 0.5 meter per second square, second power minus 1. That is the initial velocity. Acceleration we calculated 0.5. That is the acceleration multiplied with t equal to 15 seconds. Okay. So the value of V equal 0.5 plus this will be 15 multiplied with the 0.5, we will get 7.5. If you add this, you will get 8. So finally, the velocity equal to 8 meter second power minus 1. That is the final required value of velocity at the end of 15 seconds. Okay. Finally, there is we are going to recall the numerical. First 10 seconds, it covers 30 meter. And 12 seconds, it covers 42 meter. With these two observations, we have to calculate the acceleration of the car and also what is the velocity at 15 seconds. These two things we have to calculate. First, we noted the given data. At t equal 10 seconds, the distance will be 30 meter. 12 seconds, the distance will be 42 meter. Acceleration and velocity at 15 seconds, these two things we have to calculate. Among these three kinematic equations, the second equation will be the convenient. So by using these two cases, we substituted the value of t and s in this equation. We got two equations, equation 1 and equation 2. And after that, by solving the equation 1 and 2, we got the value of acceleration. And when you substitute the value of acceleration in the first equation, then we got the value of u. Then finally, we substituted the velocity equal u plus at. The value of u and a in this equation, we got v equal 8 meter second power minus 1. Okay. Okay, guys. Thanks for watching this video and subscribe my YouTube channel, Vishwaguru, a problem solver, for more videos. Okay. Because many numericals on this topic, we will discuss on our further videos. Okay. Don't forget to subscribe. Thanks for watching. Thank you.